Hello AP Environmental Scientists. Today we are going to start Unit 2 and start talking about biodiversity. Biodiversity is exactly what the name says. It is the diversity of the living things. So diversity of living things. Now sometimes when we think about this, we just simply think about it from a standpoint that the number of different organisms in an ecosystem. And so we would call that the richness. So biodiversity takes into account richness. So the number of different species but biodiversity actually goes a little bit further, because if we're talking about biodiversity, and let's say we have 100 individual organisms in an ecosystem, and we'll say that there are 5 different species in that ecosystem. Well, if there's 100 total, but there are only 5 different species, if there were 20 of each species, we would have a very biodiverse ecosystem. However, what if there were 96 of one species and then 1 individual of 4 species? And so the biodiversity would appear to be the same because we have the same number of different species, we have the same richness. However, it's very, very different when it comes to trying to identify how healthy an ecosystem is. And so when we talk about biodiversity, we actually want to not only look at the richness, but we also want to look at the evenness. And the evenness would be the number of each species within that ecosystem. And when we look at those two together, the richness and the evenness, then we can get a clearer picture of how healthy the ecosystem is, or how biodiverse the ecosystem is. And so with the help of past scientists, we were able to put together what's known as the Shannon-Werner Index, Shannon-Werner Biodiversity Index. And so basically what we're going to do today is we are going to do a species diversity lab. And unfortunately here in Iowa, our biodiversity has slowed down. It's much lower right now because a lot of our species are actually going dormant for the winter. However, rather than using different species, we actually are going to do a species diversity lab based on the different types of cars in the different parking lot ecosystems. Because we can use those numbers to understand the concept of biodiversity. And so to get us started though, before we do the lab, and you're going to have an option of either using, if you're on site, you're going to have the option of either going to a parking lot and collecting some data, or I will also provide you with data that we collected here from Liberty High School. But before we do that, let's go through an example of how do we use these numbers to determine this diversity index. So I give you a pre-lab example. We have an ecosystem, and we're going to use the data table below to calculate the Shannon Diversity Index of a hypothetical tide pool. So we have the sea anemone, the bat star, the lobster, and the sea hare. Those are the 4 species that we identified. in this particular niche, in this particular habitat. And so what we did is we went through and we counted the number of each individual species. And you can see in the data table that we have counted 22 sea anemone, we counted 13 bat star, we counted 7 lobster, and there are 16 sea hare. And we can make some generalizations, we can have some ideas about that. However, in science, we want to actually collect and use those numbers as data so we can have comparison points. And so what the Shannon Diversity Index does is it allows us to really incorporate not only just the number of different species, but the richness along with the evenness. And so in this data table, you're going to see that PI is actually the relative abundance of a species. And so in order to determine PI, and so we'll go right here, in order to determine PI, what you're going to take is NI, so the number of individuals in a given species, divided by the total number of individuals you counted. And so the first thing we probably want to do is we want to add up the total number of individuals counted in this particular tide pool. And if I find my data, you guys can be doing that as you're doing it. I'll hopefully find my data, or I can calculate it again real quick. And if you add these numbers all together, you find that you have 58 individuals in this tide pool. So now what you need to do in order to determine PI, you are going to take the number of individuals. So for example, the sea anemone, I would take 22. Sorry, not sure why I wrote 20. I would take 22 divided by the total number is 58. So basically, I'm just figuring out the percentage. Don't change it to a percentage. Leave it as a decimal. In this case, I'm going to go to 3 significant figures. And my answer would be 0.379. If I continue to move through this data, 13 divided by 58 would give me a 0.224. 7 divided by 58 is 0.121. And 16 divided by 58 is 0.276. Okay? So now that I have that percentage, what I'm going to do is I'm going to do the natural log of that. And so if you have a calculator with natural log, you just have this number in, hit natural log, and it would give you negative 0.969, negative 1.496, negative 2.115, and negative 1.288. Now what we want to determine, though, using these two numbers, we can actually multiply these two together in order to determine basically the index, the diversity for each one. And so what we're going to do here is we're going to take the P1 or PI, multiply it by the natural log of PI, and we're going to end up with a negative 0.367, negative 0.335, negative 0.256, negative 0.355. And now in order to determine the H value, which is the biodiversity index, you have to add up all of these. And so we're going to add these numbers up, okay? Because we're going to do the negative sum of pi times the natural log of pi in order to determine the H value, which is the Shannon diversity index for this particular population. And once you add all of those up, you're going to find that the H value, or the diversity index, is 1.313. Now, this number is valuable because it gives me an index of how diverse or how biodiverse this ecosystem is based on not only richness, number of different species, but also evenness. And now I can use this number as a statistical data to compare biodiversity of multiple ecosystems, which is exactly what we're going to do in our lab. And so in the lab, what you are going to do, and what we've already done for you if you don't want to go out and collect data yourself, is that we are collecting data on the car species. And so in this case, we are looking at the make of the car. Okay, so the make of the car. And we are going to, sorry about that, we are going to be determining which parking lot or which ecosystem, the teacher parking lot ecosystem or the student parking lot ecosystem, is going to be more diverse. And so I want you to think about the pre-lab predictions. Which parking lot do you expect to be more diverse and why? There's a lot of different factors that might play a role into this. And then as you're doing this, if you go out and collect data, which would be really cool if you collected it at your home school and we could do some comparisons to describe the physical location of the parking lot, the characteristics, because if we were doing this with a real population, we would want to be looking at other markers. For example, we would have to collect geographic range. We'd want to look at the abiotic factors that might influence the biotic factors and so on and so forth. And so the pre-lab questions are there for you. This data on this particular sheet that I'm using already has the number of individuals of that species filled in. And so this is data that was collected at Liberty High School. We just went outside. A group went to the teacher parking lot. They wrote down each of the different car makes. They tallied them up, and then we had a total. So we are able to now go through and look at the relative abundance of that species. And so you have to determine, using this number, you have to determine the number of P, which, if you recall back, you're going to have to add up all the individuals and take this number divided by the total. And then you take the natural log of that and multiply those together in order to get that H value. Once you have that, you can add all of those up in order to determine the Shannon diversity index, so you have evidence to support your claim and your reasoning as to which parking lot is more diverse. If you have any questions on this, please make sure that you reach out. If not, I hope you enjoy collecting some data. If you don't have that opportunity, then you're welcome to use the data I provide for you.